Hello and welcome to Python 101, session number 5. And we are talking about selection structure in Python. Right? And I'll explain what those things are, what does it encompass, and just a quick preview of what we have covered so far. Quick review of what we have covered so far is basically we've talked about strings, and in strings, we looked at the string library in the previous class. We looked at the string class, some of the important functions in the string class, and uh, we looked at strings in the past two sessions. We also looked at built-ins that will work not only on string but on other stuff as well, other sequences as well. So we looked at some of the built-ins that we looked into were sorted, chr, odd, we have looked at len so far. Now we are going to turn our attention to selection structure. So selection structure in structured languages is one of the main pillar, and it allows us to go in one direction based on certain conditions. So suppose you have code in which the program control is going in this direction. This is your, let's say this is your code, you're going top down, and then at some certain point of time you're going to make a decision. Based on that decision, either you go in one direction or other direction. You execute code selectively. That's which is why it's called selection structure. And in Python, there are many things that we're going to talk about. First of all is Booleans. So what is a Boolean type? Then we're going to talk about Boolean expressions. We talk about Boolean operators. We're going to talk about in membership. If else, and if else and elif. That should be what we're going to cover today. And we're going to look into some problems and finally assignment. So let's get started today's session. So first of all, Boolean. All the languages have Booleans. Booleans are a type of data which can be either true or false. Just like a number can be any digit or any number up to a certain range, or strings is our collection of character. Booleans is a type which can, a Boolean variable can only hold two types of values, true and false. These are special values. Okay. In many languages, they are referred as 1 and 0. In Python also, this true and false referred to as 1 and 0. So much so, first of all, let's just quickly play around with this thing. So if you write true, that is going to just print as true because that's the variable value. False. If you cast the value to an integer of true, then it will be 1. If you cast it for false, that's 0. In fact, you can write true plus 1 and that will be 2. So true essentially is a custom type for 1 and false is 0. Okay. And we're going to deal with this a lot, and you're going to be very comfortable by the end of this session. Now, true and false. We have looked at the arithmetic expressions, something like, let's say, 5 plus 9, which gives 14. Right, so this is an expression that evaluates to a result. Similarly, the Boolean expressions are some expressions which generate either the true value or a false value. Okay. And so Boolean expressions would be something like, suppose I come to the terminal again and I write 5 is greater than 4. That is a true condition. So the result of this operation is true. That's a Boolean expression which is evaluating to true. It returns true. And if you write 5 is less than 4, then this is a false because this is not a true condition. Okay, I'm going to give you time to try this out yourself. Just let me carry on for now. So these comparison operators, which generate the true or false result, what are they? Well, it can be something called equality. You can do equality, or you can do something is greater than, or finally smaller than. So equality, the operator for the equality is double equals. And if the two things you want to check if they are equal, then you will do this. For example, you can write 5 equals 5. That's a true condition. And at the same time, if you want to check if something is not equals to, then you use this. It's pretty universal. Greater than is this symbol, and you can also say greater than equals to like this. Smaller than is this, and smaller than equals is this. Sorry, it should be this. Smaller than equals to. All right, so let's just quickly try this out. In certain cases, for example, 5 is equals to 5, that's true. 5 is not equals to 5, that's a false. That will evaluate to false. 5 is not equals to 6, that is true, right? Because 5 is not equals to 6, that is a true condition. And then you can write 6 is greater than equals to 5, that is a true condition. 6 is greater than equals to 6, that's a true condition. Whereas if you write 6 is greater than 6, that's a false condition. So this is basically at least equals to this guy here. Right? So some true and false, how it works. I'm going to give you 30 seconds if you want to try this out yourself, and then I'll move forward. All right. So I'm just going to code some stuff on the IDE. Booleans are also used directly when you want to return something. For example, suppose let's write some very basic function. Suppose you want to write to see if something is even or not for a function. Okay, you want to write a function that returns true if number passed in is even. So you can call this function, for example, def is even. Very simple stuff. And it takes in a number and it will return true if this number is even, otherwise it will return a false. Okay, let's just do this and just print. Print is even, let's say 1, and is even 100. No, this can be, let's say 99. All right, so right now this function will not do anything. Now, essentially, what you can do is the Boolean expressions themselves, they return an answer. If a number is even, then you guys must know we can use a mod operator. So essentially, the mod operator will check for the remainder. An even number, when divided by 2, will generate a remainder of 0. So you can just write an Boolean expression, which is something like, let's just come here quickly on the terminal. Suppose 100. So 100 mod 2 is 0. right? So this operation results in 0. So if I write this equals to 0, that will be true. So if I want to check any number, whether it's 0 or not, sorry, whether it's even or not, I can just mod it with 2 and check if it's equals to 0 and then return that. So you don't have to first of all check this and do some kind of a if condition and then return based on that if condition, right? I'll show you the if else condition as well shortly, but you can just return it like this. So when you return, the answer is false and true. So you can just write one statement like this: return the output of this Boolean expression. All right, any questions? Hey, this is pretty straightforward stuff so far.
Himanshu, just a quick question. So why
Yes.
didn't the print function work here?
What do you mean?
So instead of when it defined is even number and we gave a number here, and when we ran the function, why didn't it return the
It did return, right? So when you
uh,
run this code, this came as
no?
this false and true, right?
Okay, the before one also return. Okay, okay. I'm sorry, I missed that, I guess.
Yeah, yeah, yeah. So it did return. Okay. So yeah, this is pretty straightforward stuff. So just for your convenience in the future, when you're doing this situation, this kind of when you are in this kind of situation, just return the output of that Boolean expression. And I'm going to give you some problems as assignments that will focus on this. Okay, so let's go a little further and let's talk about the Boolean operators. So apart from using these Boolean operations, you can combine them to make a bigger logic. Okay, so what you can do is you can say, I'm going to write Boolean expression like this. So you have a Boolean expression that can return a true or false. You have another Boolean expression that can return a true or false. Then you can use both of them. You can combine both of them with something called Boolean operators. The Boolean operators are and, or, and then there is one more called not, which we'll separately talk. It's a unary operator. These are binary operators, and this is a unary operator. That means it only needs one operand. So, and or, most of you must know this already, but based on this condition, and or will give you a combined answer. Suppose this is true and this is true, and you put an and in between, so that will result in a true. And it almost works like English language. So suppose you want to say something like, let's say if age is greater than equals to 18 and state equals to, let's say, California, then let's say true. So you can combine these two Boolean expressions here like this, equals equals, and also join them with an and statement. The only thing is, when you are writing an and, both of the Boolean expressions or any number of operations in the chain, they all need to evaluate to true. Whereas in an or, if any of this is true, so if you write age greater than 18 or state equals to, let's say, CA, then this will evaluate to true if any of these conditions are true. So let's just quickly look into this with some real conditions. So suppose that you are applying for some kind of driving license, and once again, there is an age argument and there's a state argument. So both are checked. If you're correct, if you are in California state and your age is above 18, then you get 18 or above, then you get driving license. So you just want to say, let's say, just generate a true or false combined. So essentially, you can just write state equals CA. So this will compare whether this is true or false. And you can write and age greater than equals 18. So this whole statement will return a true. Let's say you just say 19, then this will return false. If any of the condition in end is false, then essentially your answer will be false. And similarly for or, if any of the condition is true, then you're true. If both the conditions are false, then only this will be false. Now this is false because both the conditions are true. State is equals to CA, but this is lower CA. So caps C is not equals to small c. Keep that in mind. Case sensitive works here. So you can combine your operations like this with and or. You can also just directly try this. True and true is true. True and false. False and true. False and false. Similarly, you can write false or true, that is true. So or will only evaluate to false when all the conditions are false, and true will only and the and operator will only evaluate to true if all the conditions are true. Okay? Any questions? All right. And finally, the not. How not works is, it will be actually more clear in the example, but it's a unary operator. So whatever is the output of something, you can put a not in front and then it will generate the opposite result. So when you say not true, it becomes false. Not false is true. So you write 5 equals 5. That is true. And you can write not 5 equals 5. That becomes false. Many times you will have to negate. Let's say you want to say, if this string is not part of the other string, then do this. So you can do this with the not. And as we'll see in the examples. So it's a unary operator. It will work with just one expression. It doesn't need two expression. So once again, you can just write another function, something like def is qualified, let's say for driving license. And suppose it accepts two arguments, age and let's say state. And I'm just going to write return here. And suppose that I'm going to say print age is, let's say, 17. And this is, let's say, California. Okay. And we can just write a logic here. If age is greater than equals to 18 and state equals CA. So we can just return that answer. So once we run this, we get 17 CA. What did I do? Sorry, my mistake. I did not call the function. I need to call that function. Let's run this. And you will see false, because this condition doesn't match. Or you can just write something like 25 and you run the code and you get true. All right. So once again, single line statement here that will do the job. Now, how does the selection logic actually work? What selection logic does is that right now you're returning the result of these Boolean expressions. Selection logic makes a decision based on the Boolean expression. Suppose you have a Boolean expression, okay, and your code is working here line by line, and you get a selection logic here on this Boolean expression. Then based on the true or false, you can go in either direction in your code. Okay, and this selection structure, the most common one is if else. So you can write something like, if a condition and then something else something else. So you essentially say that if this condition is true, then execute this code. Otherwise, if this condition is not true, then execute this code. So you're able to choose a branch of code that you want to execute based on the condition. So let's take an example and also understand the syntax of this. I'm just gonna create a new module, say call it if else. So how does the if condition work? You write if and then some condition and you hit a colon, just like the function declaration. You hit the colon. As you hit enter, there will be an indentation. So once again, all the code block, the if code block has begun and all the code within this block has to be indented. So now you can write something, some statement, statement 1, statement 2, and once you're done, you can come back and write else. Right, statement 1, statement 2, and then you can come back out of this if else. When the time comes, this if else will be evaluated and you will get an answer.
Quick question.
Yes.
Is the convention in Python 4 spaces?
Yes, 4 spaces. All right, so let's write a real world example based on this. Suppose in this previous example, you were to do something based on, actually let's take some other example. Let's take a problem called Fizzbuzz. Okay, it's actually a game, kids game. Essentially, what happens in Fizzbuzz is that you count numbers, and if the number is divisible by 3, you essentially say fizz. If the number is divisible by 5, you say buzz. And if the number is divisible by 3 and 5, then you essentially say Fizzbuzz. Okay, so basically, kids in a group, they speak number one by one. So the first kid says 1, then the second one says 2, then third one has to say fizz. Then 4, buzz, 5, 6, fizz. I myself is doing mistake, but yeah, essentially that's how you do. So all the numbers that are divisible by 3 will be fizz. All the numbers that are divisible by 5 are buzz, and divisible by both are fizzbuzz. So let's write a function, fizzbuzz. Let's say we are just doing a simple thing. We're just passing a number in, and we have to return an answer, fizzbuzz, based on the number. Okay, so let's just say return, and we're going to call this like maybe, let's say 10 or 9 or let's say 15. Let's just keep this for now. Just say 5 or 20 here. Okay, so first we're just going to do the 9. So what can we do here is that we can write the if logic. Now notice the level of indentations. When I start the function, there is an automatic indentation that's going to begin. Here I'm going to write a condition, and I'm going to say if the number is divisible by 3, that is if the number modulo 3 is equals to 0, then we have to do something. Okay, for this something, I'm just writing a pass here. I'll explain what pass is. Else, some pass is basically an empty statement. Whenever you want to syntactically add a statement, but you don't know what you're going to do, but you still have to add something, then you can just put pass there. It's an empty statement, and syntactically this program will work. It will not complain. If you do not put anything here, for example, if you remove this, then you are in trouble. We'll say that there is an indentation error. There is the if block is empty. So pass is just an empty statement. It does nothing. It just fills the space like a placeholder. Okay. So number by 3 if is equals to 0, then essentially you can just print, let's say, fizz. Else you just print the number itself. So if you pass now 9, you get the this. And I can add one more just quick print statement here, and where I can just write number and just that. Don't worry about the syntax. I mean, you must be able to understand, but essentially 9 fizz. That's what this is. Now you can just say, let's say 10 when you write this. So 10 is 10, 9 is fizz. So essentially how you write if else block is you say if some condition is true, then do this. Otherwise you do this. That's the if else. And if else uses Boolean expression to evaluate which branch to execute code. Any questions?
Where's the pass?
What do you mean? Oh, so pass is just an empty statement. Suppose I don't know what I'm going to do here, but I still need to write
Okay.
this function. For now, I can just put pass. So pass is like an empty statement. It does nothing. It just is a placeholder for the time being. That's all.
Okay.
Your program will not fail the execute. It will not get a syntax error if the pass is there. So we just use it as a placeholder at times. Right. So let's actually, why don't we do this? Let me give you a minute to try this yourself, and then I'll extend this logic a little bit more further. Okay, so you take a minute, try this out yourself. Let's enhance this logic a bit more. Okay, suppose now I pass 20, then I should ideally print buzz instead of the number, right? Currently, when I do this, you'll get an output as 20 should print buzz. So we need to add some logic for 20 as well. And the logic here is something called else if. So we're going to say just how we say in English. If the number is divisible by 3, then print fizz. Else, if the number is divisible by 5, print buzz. So the way you write is you introduce another block, which is called else if, and the short is elif. And what you write is else if the number is divisible by 5, then you print buzz. Okay. So now when you write 20, you're going to get buzz. So that completes the whole structure of if, elif, else. So if comes with a condition, elif, if this condition doesn't evaluate to anything, like evaluates to false, then the program control is going to jump to this elif statement. If this condition evaluates to false, then you going to come to else. And then there can be any number of elifs in between. Condition and then any number of elif. Also, there is no need for else to be there as well. You can completely skip else. It's syntactically okay to skip the else. So essentially, when you print it, you will get buzz, fizz, buzz. But you don't have to print any, what you call it? You don't have to print any, have to have any else statement, or for that matter, any elif statement as well. You can just have a if as well. Let's add it back. Okay, now let's add the last logic, which is if we want to have, if the number is both divisible by 3 and 5, then you print Fizzbuzz. So I come here and I write another elif number is divisible by 5 and the number is divisible by 3, then print Fizzbuzz. Okay, now this condition is pretty simple. Let's add another number here and let's just say 30. 30 is divisible by both 3 and 5. So let's run this code and we get 30 equals to fizz. Now we did not print Fizzbuzz, but we print fizz. Can anybody guess why is this happening?
Because your first if is true, so it'll never pass your first if statement or first condition that it meets.
Exactly. So that is important with loops. Selection structure here, if else. If the very first condition is true, rest will be ignored. After doing this work here, the program control is going to jump from line number 10 here to straight to line number 17. That it's done. It will ignore everything in between. So how can we fix this problem? Can anybody tell me?
Change the order.
Change the order to do what?
Put 13 to 9. The
Yes,
num5.
exactly. So the most specific condition should go to the top and more general conditions should go to the bottom. So instead of this, you can just put if this condition is true, elif that. So the most specific condition, the most bounded conditions goes to the top. And then you do this, then you run it, essentially goes to Fizzbuzz. Now you get the answer. So this is an example in which you see if, elif, else, the use of Boolean operator, and also the order, how the order is important while doing these things.
Question, if
Yes,
none of the
please.
conditions are met, it appears that a none is returned. And can you talk about that a little bit?
If none of the condition is matched, then a none is returned. The none will be returned regardless. So let's do something. Let's just print this here. Suppose I print 10. Okay, let's just do this. When you run this, a none will be returned. Remember that we are not returning an answer in this function. We are only printing. We never wrote a return statement. If you don't write a return statement, the default return statement is going to be none. So if you want to return something, you will have to explicitly write return something. Does that make sense?
So in Python, don't we need to specify the type of return?
No, you don't need to.
You don't need to? Okay.
You need to, yeah. I mean, all of this is in the very first class that you don't have to specify the type of the return. Functions
Okay.
can return anything. You
Okay.
don't have to specify the type of the input as well.
Okay.
Any type of argument can be accepted here.
Okay.
I have a couple of questions.
Yes, go ahead.
So first, what does the 0 mean in the equal statements?
You mean here?
Yeah, the 0.
This means that if I divide num by 5, then the remainder of that division is 0.
And all right, thank you. And my second question is, why can't we do instead like else, and else?
Just a quick thing. So just to make sure, make sure that you are understanding this. So 2 by 4, if you divide, the answer is 2, right? That's called the quotient is 2, and the remainder is 0, right? And if you divide 5 by 2, the quotient is 2, and the remainder is 1, right?
Right.
Yeah. Now, what is the other question?
So you know how we have elif. Why can't we do else, and else?
No, else, first of all, else is a blanket condition which is going to catch everything that didn't qualify in the if. So if you write else here, then you will miss, you cannot write any logic. For example, if you notice, I'm saying if this condition is true, then do this. Then there is a sub condition as well. Okay, if this condition was not true, but let's say this condition is true, then do this. Okay, if these two conditions are not true, but still there is something else that is true, then do this. If none of this is true, then go to the else block. So else is going to catch everything that is not filtered here. It doesn't even have a condition if you notice. It just is an else statement. So if you had a binary logic that, for example, in this case, if you had a binary logic, if you were to write, let's say, if this condition is true, then print qualified. And then you can write else print not qualified. Then the else will work. Here, if you write else, then you will not be able to catch these conditions. Or to demonstrate, let's just put it here. And let's run this code now. Notice that 10 is 10, 9 is 9, 20 is 20. Only this is equivalent to Fizzbuzz because we could not catch the other conditions. Does that make sense?
Yeah, that makes sense now. Thank you.
All right.
So does that mean it's because we have more than two conditions?
Yes. Because we have, there is not a binary condition here. So we are saying here, there is some condition, okay? And based on the result, suppose I want to say that, okay, I'm gonna come and meet you, okay? And I'm gonna say that if the distance is less than 1 mile, then I'm just gonna walk. Else, I'm going to, let's say, drive. Okay, so that's a binary condition. But if you have more conditions in between, suppose if I'm going to say if the distance is less than 1 mile, then I'm going to walk. But let's say if the distance is greater than 1 and it's, let's say, less than 3 miles, then I'm just going to bike to your place. So you have an intermediate condition as well. It's not a binary logic. Right? So that this is going to be an if, then this will be elif, and this will be else. Is that clear?
Yes.
Okay.
Yes. Thanks for clarification.
Okay. Now let's just quickly look at some syntax part. So when we write these functions and if-else statements that we have been writing all this while, there is one slight syntax thing that you can do, okay? And that is the block size. If the block size is equal to just one statement, then you can write the whole thing in one line. But if it's greater than one statement, then you have to use multiple lines to express your logic. Let me explain this by an example. Suppose I want to define a function, okay? Let's just first use Thorny. Let's go back to this function here. If I want to define a function, it has only one line, then I don't need to start a block. By coming to the second line, the block can be just on this same line. And the requirement is that this only contains one statement. So then you can run this and you'll be fine. If you try to add anything more, then you'll be in problem. The similar logic also exists with the if-else. If just only one statement, then you can just do this. And this will be fine. For all of these blocks, all of the blocks have only one statement. So you can just write like this, and that is also fine. There is always a trade-off between readability, and code conciseness. Readability is always more important. So if by bringing the code into one line, the code becomes hard to read, then you don't bring it. Okay, usually what people do is just very small statements like this, people write in one line. Right? If it's too much of big of a logic, then you basically always use the next. You enter the block with an indentation. And essentially what you can do is you can also, it becomes easy to express it on terminal. Suppose you want to write a function def add, and suppose you want to say x comma y, and you want to return. So if you had hit enter, then essentially you're now in the block. So you add something and you say return x plus y. But this is only one statement. So you can also write it as return x plus y. That will also work. Similarly, you can say if age is greater than 18, return true. Sorry, my mistake. Sorry about that. Say print true. The if statements don't return anything. Functions return stuff. So you can just write this kind of logic. And if this age is, let's say, greater than equals to 18, then print true. We are true because age is 18. So for one-liner blocks, you don't have to go to the next line and do the indentation. You can just write everything in just one line. Okay, at this point, I'm going to give you a minute, maybe take a couple of minutes to try this out, and then we'll resume. Let's look at another very important thing here, which is called the in membership. It makes life really, really simple, and it's amazing. So what is in membership? It's something else that also returns true and false. Okay, and the in membership checks whether a particular item is present in the collection. Okay, any type of collection that you have, string, dictionaries, maps, lists, sets. So you have a collection and you want to check if an item is present in that collection, you can write just item in that collection. That's the in. And that returns a true or a false based on whether something is present. So suppose you want to write something like whether this string turn is present in Saturn. That's true. If you write turn 1 is present in Saturn, no, it's false. So that in membership is highly, highly useful to do these quick checks. All right. And also if we notice some of the, so let's first of all write this logic. Essentially, let's just write some kind of a function real quick. So you can just check. I can't think of a good example, but essentially, basically, if you want to check something is present in another thing, you can just do that in check, and that will return true. So suppose you write a function, you say def, let's just call it sub str. Okay, and let's say you have S1 and S2, and you want to check whether the S1 is present in S2, you can just say return S1 in S2. So that will generate a true and false. So essentially, we literally have not done anything in this. I'm just giving you a very vague type of an example. So let's just print sub str of, let's say, A comma B. That will return false. And let's write another example. A comma, let's say BA. Then that will return a true, false and true. So quick word on this in. There are another Boolean conditions, and if you explore this str library, let's just write some more things here. Suppose I have a name. Okay. Suppose I want to write a function which says that, okay, let's write a function first. Suppose I'm going to write a function which says starts with vowel. Okay. And suppose I'm going to say a name. So this function returns true if the name starts with a vowel, otherwise it will return false. Okay. And suppose I'm going to call this function with some names. Suppose I'm going to call it with Adam, and let's say call it with Kate. All right. So if I run this function now, it should return true if the name starts with a vowel, right? So you can basically just check if the first character is a vowel or not. How can we check that? Can anybody tell me?
Use the string. So name 0, something like that.
Yeah.
Yeah. So name of 0 equals to, let's say we can write A. What are vowels? Vowels are A, E, I, O, U. So, or we can write or name of 0 equals E, or we can write name of 0 equals I, and you get the picture. And basically return true. Or you don't even need to do that. You can just say return that. If this condition is true, you will automatically return true. So like when you run this code, sorry, I have a colon here. If you run this code, then you will get true or false. Let's print this answer. Okay, you get true and false like that. Now there is another thing that you can do. If you, for example, what are we saying? We are saying if the name, the first character is either A, E, I, O, U, any of this, then essentially you have, if the name of 0, if it's either equals to A, E, I, O, or U, then essentially you return true. Else you return false. So this condition returns true. Everything else will return false. But we have to do this in this way. Name 0, this, or this, or this. Instead, we can do something better than this. We can just say if name of 0 in a string that I'm going to construct, A, E, I, O, U, or let's say also construct a small A, E, I, O, U, so we don't have a problem. That's it. So if the first letter is present in this string here, then you return true. Does that make sense? And if you can ask a question if you have any questions. So you can use in this way, but we'll have plenty of examples. Any questions? Okay, let me talk about the assignment now. The assignment, I'm going to point you to my GitHub page, and I'm going to also send you the link, which will also be present in the YouTube description. Okay, you can look. Let me show you the assignment.